With this, I would like to start off with one of the most important as well as interesting topics in your syllabus. No, I'm not going to name that topic. You will have to guess that topic. In this topic, we are going to learn one of the most significant elements that is present everywhere around us. It includes even your friends, your family members, your pets, and everything that is there around you. Can you guess which element are we going to learn about? Yes, that is carbon. Today we are going to learn about carbon and its compounds. Speaking about carbon, let me tell you that it is one of the most significant elements of the periodic table. Having atomic number 6, it has its electronic configuration 2, 4. That means it has 4 valence electrons. Let me come up to what is organic chemistry. Organic chemistry is that branch of chemistry in which we are going to study about specific carbon compounds. This means that carbon is such an important element that it forms that many number of vast compounds, and hence an entire branch of chemistry has been given towards carbon. And that particular branch of chemistry is organic chemistry. In organic chemistry, we are going to study specific carbon compounds. I do say specific. The reason being, it is not all carbon compounds are going to be included in it. Namely, oxides, carbonates, bicarbonates, and metallic carbides. Leaving out these 4, all compounds containing carbon will be included in organic chemistry. Now the question that turns up is, what is the need of giving an entire branch to carbon compounds? The answer is very simple. Carbon forms more than 10 million compounds. And we are going to learn only a few of those, but the important ones. Coming up to what is termed as the unique nature of carbon. Here we see that carbon has 4 electrons in its outermost shell, which shows that it exhibits tetravalency. It can easily combine with other elements, forming covalent compounds. I repeat, forming covalent compounds. Now, as such, you already know that there are 2 types of compounds that you must have learned by now: electrovalent compounds and covalent compounds. Electrovalent compounds are compounds that are formed by the transfer of electron from a metallic element to a non-metallic element. Whereas a covalent compound is a compound that is formed by sharing of electrons. Now the doubt that would be coming to your mind is that I say carbon, it forms covalent compounds. The doubt that would be coming to your mind is, why not electrovalent compounds? This is exactly what you have to think. You have to question yourself, why is it like this and why not like this? So the answer that goes out here. Carbon cannot form electrovalent compounds. The reason being, you see electronic configuration 2, 4. It indicates that the number of protons it has is 6. Number of electrons it has is 6. Now, in order to form an electrovalent compound, it has to either donate electrons or it has to accept electrons. Now, in order to accept electrons and achieve that stability, we would say that it has to accept 4 more electrons. Now, if it accepts 4 electrons, you see that the total number now turns out to be 10. You see, protons 6 and electrons 10. Firstly, protons would find it very difficult to have these many number of electrons. And secondly, there would be inter-electronic repulsion because of the greater number of electrons. Therefore, carbon cannot accept 4 electrons. Now the question would be, why is it that it cannot donate 4 electrons? Now once again you see, proton number is 6, electrons are 6, and if it has to donate 4 electrons, it would require a great amount of energy. And then the number of electrons that would be left out would be 2. So here the positive charge that is shown by the nucleus due to the presence of proton, that is 6, would be far more than that of electrons, which would be only 2, thus making carbon atom highly unstable. Thus, the only option that carbon atom has is to share its electrons. I hope everyone is clear about the same. Now let us continue further. First unique nature that we have spoken about carbon is that it is tetravalent. It shows tetravalency due to the 4 electrons in its valence shell. Coming up further, the second property of carbon atom that we would say makes it unique is termed as concatenation. Let me define concatenation to you. It is a tendency of an element to form long chains of identical atoms. Once again I repeat it, try and understand. Concatenation is the tendency of an element to form long chains of identical atoms. Carbon atom shows maximum tendency of forming long chains. Carbon atom can easily combine with other carbon atoms, forming a large number of compounds. Now the type of chains that it can form what is termed as a straight chain compound, such as this you see. It can even form branched chain compounds. It can even form closed chain compounds. So you see, carbon has a tendency of forming long chains of identical atoms, and the type of chains that it can form is straight chain, branched chain, as well as closed chain compounds. Since it possesses this particular property of concatenation as well as the property of tetravalency, it can form a large number of bonds. It can form a single covalent bond, a double covalent bond, or a triple covalent bond. Such as, here you see, carbon-carbon single bond, carbon-carbon double bond, and carbon-carbon triple bond. Further, so let me just revise once again with you. Carbon forms a large number of compounds. Firstly, due to its unique nature, which it shows as tetravalency, as well as by concatenation. Now some of you might wonder why Sir has drawn for straight chain compounds single bonds, for a branch chain a single bond, whereas for closed chain compounds you see there are 4 bonds that have been shown for each carbon atom. Exactly speaking, each carbon atom does require 4 electrons in order to be stable. Hence, it shares its 4 electrons with other atoms. So here, each carbon atom has to be satisfied by 4 single covalent bonds. Since this particular carbon atom I have shown 4 single covalent bonds, I can show that for each of these carbon atoms. Thus I can put 1 bond for each, and I find that each carbon atom now shows 4 covalent bonds. Same thing can be done here, where this carbon atom has 2 bonds. It requires 2 more. This carbon atom has 3 bonds, requires 1 more. This carbon atom has one bond requires 3 more. That's correct. As this carbon atom would require 3 more. So now you see each of the carbon atoms are having 4 single covalent bonds, and hence of course they attain stability. Let us continue further. The third property that we would like to speak about today is what we term as isomerism. This is a very interesting term. First, let us understand what is isomerism. Organic compounds having same molecular formula but different structural formula are called isomers, and this phenomenon is termed as isomerism. When I say same molecular formula, different structural formula, it means that the constituents of the particular compound remain the same. Only difference is the arrangement of the atoms within that particular compound. For better understanding, I'll give you an example. We take the molecular formula C4H10. Let us draw the number of compounds that can be drawn for this particular organic compound. You see, first we draw straight chain compounds. 4 carbon atoms. Hydrogen, there are 10 atoms. That means each of the carbon atoms should be satisfied by 4 single covalent bonds. So here you see this particular carbon atom, it requires 3 more, which it will have using hydrogen. Similarly, this carbon atom will require 2 more hydrogen atoms. This carbon atom, 2 more hydrogen atoms. Whereas this carbon atom has only 1 single covalent bond. That means it requires 3 more electrons, which it will share with hydrogen atoms. So now if you count the total number of hydrogen atoms, you see that it comes up to 10. So this particular compound I have shown as a straight chain compound. Further, I can even show it as a branch chain as follows. First, carbon. I'll take 1, 2, 3, and I'm putting a branch. This is 4. So 4 carbon atoms. Once again, can each of you draw the number of hydrogen atoms that each of these carbon atoms would require in order to attain stability? Try it out in your books. Do not refer to the answer right now. I'm putting the answer on the board, but do not refer to it. First you try, and then you refer to the board. Yes. Now you can refer to the board. You see that each of the carbon atoms, it is surrounded by 4 covalent bonds. Now here, if you once again counted the number of hydrogen atoms, you find that they turn out to be 10. So once again, what do you see? What's the difference between the two? Their constituents remain the same. 4 carbon atoms, 10 hydrogen atoms. But only due to the different arrangement of the carbon and the hydrogen atoms, they form different compounds. Similarly, if you want, you can try out the same. You take the example of C5H12. Of course, I'm not naming these compounds because nomenclature we will be doing later on. For the time being, I want you to only understand what are isomers. That they have same molecular formula but different structural formula. So here I have given you a compound C5H12. I want you to draw as many number of isomers as you can draw for this particular compound. You try it out in your book, and of course then you can refer to the board. By now, I hope you must have drawn the first isomer. That is nothing but a straight chain compound. And in this, once again, I see I have used 5 carbon atoms and they have been surrounded by 12 hydrogen atoms. Now go on with the second one. Now, look at this compound. Once again, I have put forth a branched compound. In this particular compound, I see that I have taken together 4 carbon atoms in a long chain, and I have put up one branch for this particular compound. That means both these compounds, though they are having the same molecular formula, that is C5H12, but they have different arrangements and therefore we'll have their different structural formula. Thus we'll consider that these are 2 different compounds. Can any of you think about any other structure for this particular compound? Is it actually possible? No, don't do this. Don't take this carbon atom out here and consider that it is a new compound. No, it is not so. Once again, of course, about this we will learn it up in our nomenclature. But for the time being, you should be knowing that just changing the position of the carbon atom from this carbon to this carbon would not form a new compound. It would be the same compound as this. Can you think about any other compound? I can show you one more. Refer out here. Carbon atom at the center surrounded by 4 other carbon atoms. You see now, this is an absolutely different structure. Here I have taken 5 carbon atoms in a chain. Here I have taken 4 carbon atoms in a chain and attached 1 carbon atom. And here I have taken 3 carbon atoms in a chain and I have attached 2 carbon atoms as a branch. Once again, of course, we have to show 4 covalent bonds for each of these carbon atoms. Of course, if you count the total number of hydrogen atoms, yes, it will turn out to be 12. That means what I have drawn in the board for you is nothing but 3 isomers having same molecular formula but different structural formula. These are called as isomers and the phenomenon is termed as isomerism. So one of the unique nature of carbon atoms is that it exhibits isomerism. It can form a large number of isomers. Thus we come up to the conclusion that carbon has a unique nature due to which it can form a large number of compounds, and hence we require a separate branch in chemistry dedicated towards carbon and which we call as organic chemistry. So before we go on with the next part, let us once again have a quick review of what you have actually learned. Try and recollect the answers. First, carbon atom forms a large number of compounds due to its unique nature. The question turns up, what is the unique nature that has been shown by carbon? The first unique nature is that it is tetravalent. It exhibits tetravalency due to the 4 electrons in its outermost shell. Second, it exhibits catenation. That is the tendency of carbon atom to form long chains of identical atoms. Thereby it can form different types of compounds: straight chain compounds, branch chain compounds, closed chain or closed ring compounds. And of course, due to this it can even have single covalent bond, double covalent bond and a triple covalent bond. And last but not the least and the most important thing is isomerism. Carbon atoms exhibits isomerism. The carbon element shows isomerism. It has a tendency, in fact we can define it as organic compounds having same molecular formula but different structural formula are called isomers, and this phenomenon is termed as isomerism. So this is what the example that you have just solved right now shows: the compound C5H12 having 3 isomers. Of course, the naming, I'm not discussing it right now. As soon as we learn nomenclature, you will be able to name these compounds individually. But right now the important task is understanding the isomer and understanding this phenomenon that is isomerism. Further, if all this is very clear to you, you would agree to it that carbon requires a separate branch in chemistry, and that we call as organic chemistry. Further, let us now study about hydrocarbons. The name itself suggests hydrocarbons are organic compounds containing hydrogen and carbon only. Of course, hydrocarbons have been bifurcated into aliphatic and cyclic compounds. Now, when you're talking about aliphatic, it's nothing but chained compounds. It can have saturated or unsaturated compounds. Saturated compounds are nothing but alkanes having carbon-carbon single bond, whereas unsaturated hydrocarbons are compounds of carbon containing carbon-carbon double bond, which we call as alkenes, or carbon-carbon triple bond, which we call as alkynes. So what we are going to study is, according to your syllabus, would be about alkanes, alkenes and alkynes. Let me repeat again. Alkanes are having carbon-carbon single bond, alkenes are having carbon-carbon double bond, and alkynes are having carbon-carbon triple bond. Now, before we get into the details of it, let me introduce you to what is termed as the homologous series. Homologous series is a series of organic compounds which show a definite structural pattern, where one member differs by its adjacent member by the CH2 group. Let's first take the example of what I already spoke about, alkanes. Please refer. Alkanes. They have the general formula CnH2n plus 2, where n is the number of atoms. That means if I take the first molecule or the first compound of alkane, I'll take the value of n to be 1. So it would be C. Of course, I'll not write 1 because the moment I don't write any number, it indicates that it is 1. So n is 1. Here H, 2n. Once again, n becomes 1. So 2 ones are 2. 2 plus 2 is 4. So it becomes CH4. After that, let's take up the second compound. We take C. Instead of n, now I'm going to write 2. Once again, if I take a 2 out here, it becomes 2 2s are 4, plus 2, that is 6. That is C2H6. Let's take the third one. C3H, 3 2s are 6 plus 2, that is 8. Can you write down the next compound? What would be its formula? If you have got this, yes, you are absolutely correct. Now, if you refer to all these compounds, can you tell me what is the difference between this compound and this compound? Yes, it is CH2, differing by 1 carbon atom, differing by 2 hydrogen atoms. Now let's go on with the next one. What's the difference between this and this? Once again, 1 carbon and 2 hydrogen. So we come up to the conclusion that the members of the homologous series have the same general formula. That means alkanes having the same general formula, CnH2n plus 2. And one member differing from its successive member by the CH.